Welcome back, Algebra 2 class. Have we got a show for you? In life, you need good friends. And if you had been here maybe 10 seconds ago, you would have heard quite the amazing sound. I'm sure I can repeat it. You've tuned in to Lesson 72, at least the first part. We'll have another one on logarithms in the next episode. So tune in for that. See if we can get that whole lid up there. Oh, golly! Today is Witch Hazel Wednesday, day 2 of the coronavirus scare emergency education plan. Lesson 72: using the properties of logarithms. I'm going to do the first 2 rules today. I'm going to tell you some basics about what logarithms, how they work as graphs and inverses of exponential functions, and then we'll look at some of the rules, and they'll be like, "That's a rule?" I'm like, "Yeah, that's a rule, and you need to follow it." So, if you've got your reference sheet, which you should have, there's some logarithm properties right here on your sheet and those are basically all we're going to be looking at here over the next couple of days. And then I'm just going to demonstrate how they work and show you some pictures and maybe ask you to graph some stuff. Logarithms could be your friends. Okay, so just in review, we've got 2 different forms for the same basic type of thing. We can have some number that we would rather write, like a big number, rather write as a smaller base to a power. Make it a lot easier for us to play around with it. So this is called exponential form. We've been using exponents. This is b to the L equals n. L for logarithm, and n for number, b for base. That whole system can be rewritten this way. Log base b of some number equals L. In this case, we're solving for what would be that exponent. If we had something, a big number, but we want to rewrite it differently. Okay? And typically, we work in base 10 or in base E. We'll get to that and look at those buttons again on your calculator. Let's start with an equation like this, and I'll put this one in red. Equation like y equals b to the x, our standard like parent function for an exponential equation. I kind of wrote that backwards, but that one will go like this. Remember, it scoots along here, and then all of a sudden it goes, whoa, and off it goes. Okay, so this is y equals b to the x, our friend, the exponential function. Well, logarithmic functions have a very similar shape, except it's an inverse of the exponential function. So we would map it over the line y equals x. Color change. We would have something like log base b of x equals y. And that one would graph like this. Come along this way, and then it hits 1, and then off it goes, kind of off into the distance. So if you would like to try this on your calculator, then you could maybe graph, let's turn my plot off. You could graph, let's just do something like 2 to the power of x for fun. And then you'd want to do log base 2, and you can find that. Oh, golly, get out of there. You can find that using your alpha F2 key. The log base number 5, log base 2, and then in parentheses put x. Here, I'll show you what I want that to look like. Number 5, log base 2 of x. Okay. Zoom 6, this bad boy. Exponential and logarithmic. Oh, it's hard to see there with the shine. There you go. That's, you can almost see it now. Hang on. Will work for me to turn lights off? I'm gonna see. Hang on a sec. Changing the lights didn't work. All right. Here's my graph. My graph sees. Maybe. Oh, there. Oh, perfect. Now you can see blue exponential, red logarithmic, and y equals x there in the middle. They're inverses. They're inverses of each other. Let me demonstrate that. Okay, if we take the equation y equals log base b of x, and then we change that into the exponential form, that would be b to the y equals x. And remember how we go and find inverses? We're going to switch the x's and the y's. So let's go look for the inverse of this exponential equation, and that would be b to the x equals y. B to the x equals y, or y equals b to the x. So there we did. We had logarithmic, the blue one. We change its form into the exponential form, and then we find its inverse, and we get the red line. Okay, so they undo each other, exponentiation and taking the logarithm of something. Those are inverse operations. They will undo each other. They're inverse functions. Special classes of inverse functions. Yeah. Right. Now, because this relationship was true, that these are inverses of each other, that's going to lend itself to our first property, our first rule. Okay? And it's going to look, I'm going to get rid of the picture here. Now we're just going to deal with the actual math problems. Rule number 1, the inverse property. And here we go. This is what it looks like. B to the stuff equals x. And log base b of some stuff equals x. These are inverses of each other. I'm going to treat all this just like stuff, like that's equals to y, right? And we can see here that log base b of b to the x is x. There you go. Now, what in the world is that going to look like? You're going to have something like 2 to the power of log base 2, 7. And I almost always just put kind of like an imaginary equals x in the problem. And then you want to think, well, if I change the form of this, this is a log base 2 of x equals log base 2, 7. If you change the form, folks, that's what would happen. You'd have log base 2 of x, that's the number, equals log base 2 of 7. So what's x have to equal? 7. Sitting there in the same place. It's same log. It's like having the same base, but then looking at the exponents. So that's that part of the rule right there. If the base down here and the base in your logarithm match, then your answer's sitting right there in that little slot. So look here. 2 and 2, they match. The answer is 7. The answer to that is 7. Right. Over here on this side, this is basically saying the log base b of this thing. If we change the form, log base b to exponential form, this one becomes b to the x equals whatever was over here, the number, which is b to the x. It's just like an identity thing written in a different way. Okay? So what would a problem look like using this property over here? It will look like this. Log base 2 of 2 to the 7th power. What does that equal? It equals 7. We will eventually get to a rule where we're going to take this 7 and we put it down into the front, and then we'd see that log base 2 of 2 equals 1, and 7 times 1 is 7. All these things will kind of compound, and you'll see how they all go together. But this would be the setup. Again, we're looking for a match here between the base of the log and the base of this number, and our answer is the logarithm or the exponent. Pretty straightforward. At first, you'd be a little confused just with the form that these things come in, but I think you'll get it. Make sure that you've got that rule written down. You can also find it on our logarithm properties over here. Okay, just a little hint here. We've got a couple of buttons on our calculator that I want you to make sure you understand. You've got log and you've got ln. Okay? The log button there, anytime you push that log button, you're basically asking for log base 10. You'll just say log, but it's understood that that's a log base 10 operation that you're doing. ln stands for logarithm natural, or the natural logarithm. Logarithm natural. And it was developed, I think in French, so they'd say logarithm natural. When you push that button, you're doing a log base e, as in the number e, as in 2.7182828459045, etc. Just so you know, that's used in calculus. We will be using that. It comes in when we were doing exponentiation, right? Remember that? So I want you to know that this is called the common logarithm. I should put that on here. 2 m's, at least in California. Common logarithm, and this one's called the natural logarithm. Yes. Now, logarithms can be to any base, because if you want to write a number, you can write a number as a smaller number to any power. Really, it's super duper flexible. If you want to write 64 as 2 to the power, or 4 to the power, or 8 to the power, you can. You're in different base systems. You're in base 2, or base 4, or base 8. You can even write 64 in base 64. It'd be 64 to the 1. It's kind of stupid, but you can do that. No, it wouldn't be stupid. I shouldn't say that. Computer geeks use it. Use base 64 sometimes. It's time for rule number 2. Rule number 2 is called the change of base rule. And our calculators these days have done an end around so that we don't always have to use change of base, but I want to show you that it's true all the time. Okay, so if you use your alpha F2 thing, you know you got their number 5 where it's got log base, and when you push that button, it lets you type in any base that you want to. Okay, let's imagine that this is 2004 or 2005, and that button doesn't exist yet in the Texas Instrument world. Then all you have at your disposal is your brain and like powers of numbers in your head and base 10. Okay, and we're going to imagine that we got something that's in a base that we're not so happy with, a base 5 or a base 7 or even a fractional base or a decimal base or something like that. Here's the rule. We're allowed to change our base to whatever we want to. Base 10, base E, so we can use those buttons. We're going to change that base to some other number. And if we do that, we're going to take the logarithm of the x, and we're going to take the logarithm with our new base of the base number. That's the rule for change of base. It's a brilliant rule. It is an end around. When you get stuck in a base system that you don't like, you can change it into a number that you do like and then proceed. So let me give an example of this. Log base 2 of 7. Let's say we're only allowed to use our log button, our natural log, or a common logarithm button. If I want to change this into log 10 or base 10, okay, here's what I'm going to do. I'm going to go use the log button. Remember, log button is log base 10 of 7 divided by log of 2. And you have to do log 7 over log 2. You can't do log of 7 halves. You can't do that. Okay? Or you can do log 7 minus log 2, but we'll talk about that some other day. No, we can't do that either. It won't work. That will get you the same answer. And so let's demonstrate that really quickly. If we give ourselves a little fraction bar, and we go use the log button and not log 2. Log 7 over log 2, we'll get this approximate answer. There we go, 2.8 and change, right? Now if we do it the cheater way, which is lame, we type in log base 2 of 7 using the little magic key, then what do we get? Oh, sweet spot. We get the same thing. Because calculator basically does change base. It does change base. That's what its computer program is set up to do. Another cool thing is that you could even do this one, ln 7 over ln 2. And the further on you get in math, when you see log, it actually in calculus, if you say log, you actually mean natural log. And that's what your calculator would do. So go ahead and do fraction bar again. This time use the other button, the ln button there, and go ln 7 over ln 2. And lo and behold, you should get the exact same answer as the other one, so you can see their equivalent. You can change it to whatever base that you want to, and you're going to get that answer right. I think that's pretty cool. I had to learn it the old-fashioned way. You're wondering, like, why don't we just always use our little button? I'll show you how you can just use your brain. Your brain's a pretty good button. Watch this. You got something like numbers that look kind of familiar to you, right? Alrighty then, you could do log 10. You could do log, I want to do log 2. Because these are both powers of 2. So here's what I'm going to do. I'm going to go log base 2 of 8 over log base 2 of 4. Now, this one up here is saying 8 could be rewritten as 2 to the what power? Right? Okay, so that top is 3. And this bottom thing here is saying I could rewrite 4 as 2 to the power of. 2 squared is 4, so the answer there is 3 halves. That's the answer to this problem right here. I guarantee, try it on your calculator. I'm right, because I'm dope, and you're not yet. Think about this. If I was going to take this problem, log base 4, 8, and put a equals x, like let's solve this thing. I change it around into exponential form. I'd be saying now 4 to the x equals 8. Oh, that's a little clunky. But I know that 4 is 2 squared, so I'll go like this. 2 to the 2x. And I want to rewrite 8. I already know how to do that. I can go 2 cubed. And this problem is basically saying my answer for x is sitting right there. I'm looking at for when 2x equals 3. And, of course, that would have to be 3 halves. 3 halves would make this equal to that. They got the same base, so their exponents must be equal to each other. That is pretty stinking cool. I need no calculator for that problem. I am smart enough to do math without a calculator. Thank you very much. Thank you very much. Now, in your book, there is a little exploration thing here on page 513. I would like you to try that. It's pretty cool. If you do that, you'll actually maybe discover how a couple of the next rules work. I definitely suggest that you try that before you just say, oh, that's what the rule is. I guess I'm just going to believe it, because why would they lie to me? No, don't do that. Now, I've already emailed you your homework. And again, we've had the boys been popping in. The girl lives at my house. So feel free to come in and get some help with that. But yeah, that should be enough to help you with at least the first part of the logarithms. And once you start working with these problems, you'll see that they're actually pretty handy and go by pretty quickly. So good luck with that. And we're praying for America these days that we'll all make it. All right. God bless you and happy mathing.